constructing the understanding, they wanted you to graph a whole bunch of things. That's going to make your graph really busy and take us a lot of time. We could do this horizontal compression and graph it. We could do a horizontal compression and a vertical compression and graph it. But what we're going to do is we're going to develop a strategy that we can do all of these things all at once and combine them together. So all you need to know is what your original parent graph looks like. In this case, it's the square root of x graph. Then notice the numbers that are changed. First of all, how do we know it's not a square root graph, an absolute value graph? How do we know it's an absolute value graph? Well, we see the absolute value slides. What has changed? There's a number out in front, some numbers inside, and a number outside at the end. I labeled each of those and what they stood for. Then we're going to take points on our original graph, and I chose 4 and 4 and negative 4 and 4 because I knew I had to multiply my y values by a quarter, so I picked numbers that would make my mental math a little bit easier. Sometimes you pick different numbers that you end up with fractions. It's not wrong, it's just more annoying. So choosing points early might make your life easier. And what we do is we set up the arrows like we did before, but instead of doing it all at once, we do our stretches and reflections and compressions first. So that's where I said, I know I have to multiply x by half and y by a quarter. And then I do my translation second. I know I have to go 3 left and 4 up. So I did that math. It is so easy to make mental math mistakes in here. I didn't do it on purpose, but did you see I made like 4 of them? Well, I was just struggling to add 4. I'm not sure why it was so hard for me at that moment. But double check and take your time while you're doing the mental math. It is all super easy, but it is super easy to make a mistake. And usually when we're doing super easy things in our life, we start thinking about what we should do next before we finish what we're doing. Has anyone ever made a stupid mistake because they were just like, oh, I was already thinking about what I had to do next? Right? And you see it in everything. You see it in sport, like football. They love to say, oh, he started looking the next way to run and forgot to catch the ball. So take your time, double check your answers as you're going. And then, now that we've got our 3 new points, I'm going to plot those on the graph. I have negative 5, comma 5. That is also in the wrong spot. Here we go. Negative 5, 1, 2, 3, 4, 5, comma 5, that would be right there. Negative 3, comma 4, that would be right there. And negative 1, comma 5. So I've got my 3 new dots. Maybe I'll just label the vertex negative 3, comma 4. Because once I've labeled a couple of points, the scale of my graph is given. So then all of the other points become obvious because of that scale. And so now we graph the black equation, which looks complicated, just by going through all the transformations we've learned. What changes what and how it works. And we do that in 2 steps. We can do our stretches and compressions first, and then do our translations second. So with that, we can go to example 1. Here's the graph. Sketch and label its image after a vertical compression by a factor of 1/3, and then a translation 2 up. So if we look at the points that we're given here, we start with negative 5, comma 3. We have negative 2, comma negative 3. 1, comma 0, and 4, comma 6. And if we show all of our work, And this might be one that you could say, well, in my head, I think I could do this directly. That's fine. But as things get more involved, these kind of steps will make sense. So what we're going to do is we're going to do all of our stretches, compressions first. We know the only compression we have is that y is getting multiplied by 1/3. And then translation second, we know that we have to go 2 up. Does it make sense that your x values are never going to change then? So I'm going to just really quickly rewrite all of my x values all the way through, because they're never going to change. I do compressions first, so I have to multiply my y values by 1/3. And then take them and move them 2 up. And what you probably didn't notice, because I did it quietly in my head, is I double checked each of those numbers as I did them. And now we can plug those points in. I have -5, 3 in blue, -2, 1, 1, 2, and 4, 4. Connect the dots. And our sketching is done. Okay. I reread the question, and I feel like I haven't done this part. Technically, I do not have to say where the points are because the scale is given on the graph. So when I look at that label, maybe they want the equation. So what I'm going to do to label this is I'm going to write the equation. Y equals, in terms of g. Both of these things are vertical, which means they happen outside of the function. The 1/3 happens outside of g of x. The +2 would happen outside of g of x as well. So there is my equation of my graph, and it is labeled. Okay? We are also, I want to point out something interesting that happens in the example that the textbook has done. So I'm going to go back to the textbook example. We're going to make it a little bit quicker. I'm not going to do everything. You would have to do x by 1/2, and then you would have to do 3 units left. And we could do the same points. That part would be easy. I'm not going to redo that so that we can save some time. Okay? But I am going to talk a little bit about the equation, because this is where we have our first tricky thing of the year. Okay? First thing that you guys are going to forget often. So we're going to write the equation, and the question is, this is inside, this is inside. X's are liars, so I need something to happen inside, and I'm going to do it in blue, and I'm going to do it in green, and one of them is going to be right, and one of them is going to be wrong. Okay? X by 2 is a liar, so I need a 2x. And 3 to the left is a liar, so I'm going to need a +3. I could write it that way, or I could write it this way with the x plus 3 in brackets. Those two are different because with the brackets I'd have to distribute. This is really 2x plus 6. And this is 2x plus 3. One of them is right, one of them is wrong. Okay? I guess you could go back to the question we started with, and it would give you a hint which one is right. Did the question we started with have brackets? or not brackets? It had brackets. So in our question, this one is wrong. And it is the one that you will write more often than the right one. So we have to write a special note. And maybe you can write this at the bottom of page 221. Maybe put a special note. When you have stretch slash compression slash reflection. And a horizontal translation. The stretch, the reflection, the compression has to be factored out. It has to be written in factored form. Technically, the blue one is only a horizontal translation 1.5 units to the left. When I factor that 2 out, it would change the 3 to 1.5. So unless it's written in its factored form, we won't be able to tell how much it's translated left and right. And it's a very typical thing the exam likes to, like, if they have a choice, what do? They don't write it in factored form to try to see if you catch that, right? When you're writing it out, it's so easy just to write 2x plus 3 because it's like everything you wanted to see, but you forgot the brackets. Question?
If the plus 3 wasn't there, you don't need to do brackets.
If the plus 3 was what?
No.
If the plus 3 is not, like there's just no number, then you don't need extra brackets.
Okay.
Okay? Technically, if you had written 2x plus 6 as your equation and answer, it is right. But it just doesn't show you the 3 to the left as well as written there. I had one student 1 year set a reminder in their phone at like 10 p.m. every night this came up. It's like, oh yeah, I gotta remember that. We're gonna get so many things in this class that you need to remember. If you start doing that, you're gonna have reminders from 10 p.m. till midnight of all the important things you're gonna need to remember. But this is the first one that is going to cause you a few headaches. And some of you will be very good at making this mistake and losing points on your test. But we will try, I'm going to remind you often about it, and we'll have lots of questions that come up. Questions you can circle are 4, 5, and 6.